Hi guys, good morning. How are you? Today's topic is CSWIP 3.1 Welding Inspection Practical Plate Inspection. This is under course WIS 5. This is very informative subject, so please watch from the beginning to end. All the plates are here. What you need to, which people are need to give exam for CC 3.1. Those for practical plate you can see all plates here with defects, how it is long is coming, from where it is coming. So this is very informative for this today's topic. So you can see here the practical plate inspection. So they will give the practical plate and how we'll have to inspect it and how we have to write and what is acceptance criteria and how we have to accept that joint. So everything you can today you can see here. So you can see here test piece Indian one. This is your paper. They will give this paper to you and one old plate. So you have to check from the old plate and you have to write from here like this way. Name, your name will be here. Signature, test piece Indian 001. Code specification, which code you have used. Welding process, it is already mentioned MMA, SMAW. Joint type is single pivot. Welding position flat PA, length and thickness of the plate 300 mm into 10 mm. Date is here. So you see measure from the this datum line. So whatever you have to measure from here to here. Now you have to see this is your weld. From here to here this is the weld. From here, so this is the datum line, you have to measure from here to 51 mm for the slag inclusion is there. What is the length of slag inclusion? 8 mm. Same here you have see above 87, from here 87 mm length for, you can see here 22 mm is the lack of sidewall fusion. So you have to measure from this way. Now 153, from where you have to measure from here, from the datum line from here to here, this is 153 mm, and there is a center line crack is the 40 mm. So you have to check all these things you have to need to do here from the weld plate. Whatever you are seeing in the weld face and weld root, you have to put here actual defect. What is there? Note is the cap height is 4 mm, weld width is 12 to 14 mm. So you have to mention also here 12 to 14 mm. Toe blind is 4, misalignment is 2 mm, angular distortion is 3 mm in 50 mm, spattered along weld length or scale on the plate surface. So this is one is the weld face. Same here, you can see here the weld root. You have to mark also in the weld root what are the defects are there. Same here, the left side is the measure from this data image is mentioned. From here you have to measure. Root concavity 2 mm deep, too deep, means 23 mm far there is a root concavity 10 mm length. Okay. So this I have to measure from here. Penetration height, what is the penetration height? 4 mm. Linear misalignment is 2 mm. Angular distortion is 3 mm in 50 mm. Now this is you have to measure from weld face and the weld root. Now you can see here there is a specimen number and you have to put here the all what is the acceptance maximum allowable allowance and what is in that based on section table what is coming, and if it is acceptance inside the criteria then it is accept, and it is beyond the acceptance criteria then it is rejected. So you can see here, just take example, incomplete filling AC, the section 1. This is section 1. This is the test in the test piece 1. You can see A to C here. A to C. The weld face. The what is there? Lack of sidewall fusion is 22. So you can see here lack of sidewall fusion. You see here lack of sidewall fusion A to C 22 mm. So none. Maximum allowable allowance there is none. Means There is no acceptance criteria for this lack of fusion, so totally it will be rejected. So you have to check from here for this A to C test piece. Everything is mentioned here from here, and what is the acceptance criteria and what is the maximum allowance, and you can see in that basis section table. In this section you can see here, this is the permitted. What is the permitted is mentioned here: imperfection, comments, allowance, cracks, all types of cracks, everything is mentioned here. So you see here, A to C 4 mm, Echo total to A to C poor blend smooth 22 mm, 22 is, you see here, incomplete filling also 22 mm, means maximum allowance is none, so it will be reject. Then slag inclusion 70 mm long, 50 mm maximum allowance, so it will be reject. So it's not comes under on the acceptance criteria. You can see crack, lack of fusion, and the arch tight all will be the rejected. Okay, and misalignment and the 2 mm is 2 mm, the 15 table number accept. So if it is, you see here, the misalignment is 2 mm is there, but allowable allowance is, maximum allowance is 2 mm, so it is accepted. So this is, you have to, your specimen for, this is the old phase. If you go the root defects, so you have to find out the root defect from the old phase, old root. Excess root penetration is 4 mm, so 2 mm is the maximum allowable allowance, so it will be reject. Incomplete root penetration A to C 50 mm, should none, so it will be directly rejected. So this plate has examined to the requirements of the code specification and this rejected accordingly. So this plate will be rejected. Comments: request MPI testing to confirm crack and length. So you have to check the MPI testing for this, confirm the crack, how much it is coming. Large amount of spatter on weld face, recommend this is removed and re-inspected. If it is large amount of spatter is there in the weld face, then you have to remove and it will be re-inspected. Recommended arctite at ground flash prior to MPI testing. Then you have to arctite first, you have to ground flash, and then you have to do the MPI to testing of cracks. And this is your the inspection practice specification. So you have given the this CSWIP 3.1. When you are giving the practical plate examination, they will give the acceptance criteria this page. So in this page you can understand the each, so this page you can understand the each acceptance criteria, which is permitted and which is not permitted. In that basis you can select the acceptance and rejection. So I think for this page now you understand all this page, how you have to write in the weld phase and how you have to write in the root phase. So now is the coming, just 1 minute. Now you can see here the plate sample 6A. This is one of the sample, it is mentioned in there, in your, when you are getting the plate, it's mentioned the 6A. This is the identification number of the plate. Now this is the cap, this is the cap, you can see here cap. So what is the process of mmw? SMW. So this is the welding process. So you can see here, this type of plate you can get, you will get, not you can get, you will get in this your exam. So this is, you have to check. Now don't go every plate you can check from here, from this page. So it is very helpful for them, those are doing the CSWIP 3.1 practical plate examination. You see here, this is the slag inclusion, you can see here the slag. So you have to take from here to here and how much length is coming, so you have to mention in the, I already told you in the how it is, how you have to write in the root and the weld. You see here the cap undercut intermittent, cap undercut intermittent, this is the arc strike, this is the lack of fusion. You can see here the porosity here and the porosity here. So this type of, so you have to understand the defect, what defect is there, then you can easily write there. so weld and the root face, and definitely there is a pipe and there is a weld. The page is totally different. So in the examination, the plate, pipe should be different paper. So plate defect will become in the plate and the pipe defect will become in the pipe. So this is the welding process. You can see here MMAW, SMAW, how it is coming, the how it is looking like. This type of welding defect will cover same things. You can see here the welding process MMAW, SMAW, plate sample, 6 a root. So this type of defect will come there. Excess penetration. You can see here the excess penetration, surface lack of root fusion. This is root undercut, and the gas pour here, excess penetration, and the linear misalignment. So these are the spatter and surface slag require removal. So this spatter and the surface slag should have to require removal. Now 6B, there is another plate is there. This 6B name is there. So this type of plate maybe will come in your examination. So you can see here incomplete field groove, how it's looking like. Here, lack of sidewall fusion, the surface slag is here. This is the porosity and the lack of sidewall fusion also here. So this is their overlap and excess cap height full old metal length. So this is the things you have to check in your examination, and this will be very helpful that the same plate maybe will come there. Surface slag requires removal and the poor toe blending in full length. Now this is the second page root. Now with the second test piece is the root. So welding process, this is the lack of root fusion. You can see here root is not fused here. This is the crater pipe here. This is the slag inclusion inside. This is the lack of root fusion. Fusion is not melted, so this is the lack of root fusion. This is lack of root fusion also from here to there at the end. So this is the two test piece we have finished now. Now is you have to go. There is another test piece is looking like is the, so you have to 100% you will get this plate only for, at your exam. Cap undercut is here. You can see surface slags and pattern slag inclusion, and this is incomplete field group. So you have to understand that this the defect will come how it is looking like. In that basis you can put your acceptance criteria or rejection criteria in your test piece, and from the how much distance it is coming and what is the defect at there, so you have to write there. You see, this is the welding process FCRW, how it is looking like the FCRW, mechanical damage, one through, excess penetration, the lack of root fusion. You can see here, lack of root fusion. So, if you see the lack of root fusion in the 3-4 test piece, so you can easily understand this is lack of root fusion, how it looks like. This is very important. The welding process, this is another plate, is the 6D, is the cap, how it is looks like. Excess cap height, excess cap height is here, excess cap height, cap undercut. So excess cap height, how this is accept or rejection, how you have to know, you have to check there that page. I already told in the third or fourth page there is they mention the acceptance criteria. So from here you have to check and you have to confirm that it is accept or reject. Porosity, cap undercut, lack of sidewall fusion, cap undercut, here also incomplete field groove, everything is there. So you can understand here. Plate sample 6D, this is also the root. 6D, this is the face and the cap, and this is the root. You see mechanical damage, how it looks like. You see here mechanical damage, lack of root fusion, lack of root fusion. This is the cap undercut intermediate. You see there is a 6E cap, there is another plate. So this definitely it will be helpful for you. So all plates will be here. Cap undercut, intermediate, incomplete field group, excess cap height, incomplete field group, and the cap undercut intermediate. This is the root, the same plate. You can see here 6C cap and the 6C root is here. Lack of root fusion, excess root penetration, poor stop and start, and cutter pipe. So you have to understand this is the definitely will become here. Poor stop means welding is finished here, after that they start again. So it is coming like this way. Poor stop and means poor. This is not the technique steel welder. That's why it is coming like that. The cutter pipe, excess root penetration, lack of root fusion, cutter pipe. So all these defects will be there. Welding, all types of welding process. This is the 6F. Then another plate is there. It's looking like that. Mechanical damage, lack of sidewall fusion, poor time blend, poor poor toe blend. You see here the toe blend is very poor. Lack of sidewall fusion, incomplete fill groove, arc strike. So this will be the your defect. You see here the same here 6F root. Poor stop start, lack of root fusion, cutter 5. So how many plate is already discussed? This is the 6F. Means 6 plate already is done. A, B, C, D, E, F. So this will definitely will help you. You can see here the 6G. Another plate. How it is mechanical damages happened here. Arc strike, lack of sidewall fusion, arc strike. This is the plate corrosion. This is the another 6G. This is the 6G cap and this is the 6G root is coming like this way. This type of plate is the corrosion, plate corrosion. Current material gas cavities, poor stop start here. Note, surface slag require removal, plate corrosion require wire brushing. So you have to need wire brush here and the surface slag you have to remove by grinding. Incomplete fill groove. You see there is another plate 6H cap. This is the cap welding process, incomplete fill groove. Arc strike is there, arc strike. So this is your incomplete fill groove. So you have to write from here to there. You have to mark, and after that you have to check how much length is coming. The incomplete fill groove you have to write there. Same here, cap undercut, cap under intermittent, arc strike. So this is the root. This is 6H is the cap and the 6H is the root. You can see here the same type of defect is there. In the previous arc strike, lack of root fusion, crater 5, excess linear misalignment, lack of root fusion. This is another one plate. This is 6I. You see here 6I, arc strike, crater, cap undercut. Okay. So definitely when you are seeing, so no need to explain. This is you can understand easily. Those are the actual want to do the 360.1. How it looks like every defect should we know. This is another one. Is this is 6i same here. The 6i cap and the 6i root is here. You can see here the all defect is here. Mechanical damage, lack of root fusion, burn through. This is the another one 6j cap. Wall is the you can see the SMW MMW welding. Suspect scatter cracking. How it is taken? Suspect scatter cracking. You see here from the beginning of the well. Cap undercut. Arc strike. You can see here the arc strike. So all these defects are here. This is the root welding. This is the mechanical damage. You see how it is mechanical damage. This is this type of defect. Lack of root fusion. Penetration. Mechanical damage. You see grinding mark. This is the mechanical damage. This is the another plate is cap. Cap undercut. So cap this plate is not too much defect. It's looking like good welding. Still we have the defect here. You can see a cap undercut, cap undercut. So this defect we need to see. This is coming under acceptance or rejection. This is the root welding process. You can see the ground flush root. So you should not do the any grinding or flush root here. You can see here root undercut, intermittent, arc strike is a lack of root fusion. This is the another plate and the last plate. So how many plate you have seen here? 1 2 3 4 5 6 7 A B C D E F G H. 8 plate is there, and this 8 plate will be come definitely in including in your examination, practical plate examination. So arc strike, mechanical damage. You can see here surface lag, cap undercut, mechanical damage. So mechanical damage seek advice on course of action, excess cap height, and poor cap profile throughout. Arc strike require blending and crack detection. So this type of defect are there. So this is your last plate. You can see here the plate sample, H8 root, how it is coming. So spattered. This is your lack of root fusion, and you can see the root undercut from here to here continuous. So I think this from beginning to end, if you read thoroughly, if you understand, if you watch properly the video. So I think all people will get will get understand the how it is coming, how it looks like the defect, and how it is measured. So this is the very helpful for them. Those are want to do the CC 3.1 welding inspector. Anyway, thanks for watching the video. If you have any comments, please just let me know in my comment box. And if you want any clarification for that, I am here to give you the clarification. And if you need to know anything about the CC 3.1, any welding inspector, any questions or any patterns, so no problem. I will upload one video on that basis about the CSWIP 3.1 exam pattern. Anyway, thanks for this watching the video. Don't forget to share and subscribe my channel to get more interesting topic. Thanks a lot. Good luck.